Dear colleagues, let's consider the case of multi-criteria linear programming problem. For this case, we will construct Pareto frontier. A company produces three types of the product. In the table, marginal profit and pollution and also resource consumption are represented. Resources of the company are the following: 1,300 working hours and 1,000 units of resource. There are two goals of the same importance. The first goal is to maximize profit, and the second goal is to minimize the pollution of the environment. Consider mathematical model of this problem. We start mathematical model with definition of the variables. Company produces three types of the product, so there are three variables in this case. We denote with x1 the number of units of the product 1 produced during the planning period. The same way we denote the variable x2 and x3. Consider a production plan of x1, x2 and x3 and denote the production plan with x capital. We consider multi-criteria optimization problem, and the first criterion is profit. Marginal profit for the first product is $10. So if we produce 1 unit of the first product, we get $10. If we produce x1 units of the first product, we get 10 times x1 as profit. The same way we may calculate profit for the product 2 and product 3. And this is the first objective function of our problem. It is profit, and we need to maximize this. Also, we should consider pollution, which we need to minimize. If we produce 1 unit of the first product, amount of pollution is 10 units. If we produce x1 units of the first product, the amount of pollution is 10 times x1. Also, we may calculate pollution for the production of the product 2 and product 3. And objective function for this criterion has the following form. We need to minimize pollution of environment. There is no more criteria in this problem. Let's consider restrictions. If we produce 1 unit of the first product, time consumption is 4 hours. And if we produce x1 units of the first product, we need 4 times x1 hours. Also, we need the time to produce products of the second and the third type. Let us summarize all the time consumption for the production plan X capital. Company has 1,300 working hours. Let us finalize the first restriction. The second restriction is for resource consumption. If we produce 1 unit of the first product, we need 3 units of resource. If we produce x1 units of the first product, we need 3 times x1 units of resource. Also, we need resource to produce product 2 and product 3. Consider the total resource consumption. Our company has 1,000 units of resource. Taking this into account, let's finalize the second restriction. Also, we cannot produce negative amounts of our products. Let's consider corresponding sign restrictions. Math model is ready. Let's continue with Excel solution. Parameters from the left-hand sides of our restrictions, marked with blue color, we set into the table from B2 till D3. Right-hand sides 1,300 and 1,000 we insert into the column G. Marginal profits 10, 9 and 8 from the first objective function we insert into the 5th row. And coefficients of the second objective function 10, 6 and 3 we insert into the 7th row. Variables will be in the red frame. For instance, x1 is in the cell B10, x2 is in the cell C10 and x3 is in the cell D10. Let's consider the functions. The left-hand side of the first restriction we insert into the cell E2. Left-hand side of the second restriction we insert into the cell E3. The first objective function Z1 profit we insert into the cell G5. And the second objective function 10 times x1 plus 6 times x2 plus 3 times x3 we insert into the cell E7. This is the multi-criteria optimization problem. To construct Pareto frontier, we will use main criterion method. Let's choose the profit as the main criterion. If we have only one criterion, and also if we look at this mathematical model, we see that all the functions are linear. As a result, now we may consider linear programming problem, for which we are going to maximize profit subject to given restrictions, and also we will calculate pollution for this problem. To find optimal solution to linear programming problem, we will use optimizer solver. To install solver, we go to the file, we open options, we choose add-ins, we push go, and we choose solver adding. After that, we go to the data and open solver. Our objective function is profit because we assume that this is our main criterion. Objective function for profit is in the cell G5. We need to maximize profit, so we choose the option maximum. Our variables are in the red frame. It is the production plan. And let us add our restrictions. The first restriction is for time consumption, the second restriction is for resource consumption. And also, sign for both these restrictions is less or equal. Therefore, we may choose both left-hand sides. The sign is the same, less or equal, and we may choose both right-hand sides. Also, we should take into account that all our variables are non-negative. To add such a restriction, we should choose make unconstrained variables non-negative. Now we are ready to find an optimal solution. Solution is found. And we see that if we produce 0 units of the product 1, 300 units of the product 2, and 200 units of the product 3, our maximum profit is $4,300. This is the value of our main criterion. Also, we found that pollution for this production plan is 2,400 units. To construct Pareto frontier, we assume that our status quo point is 4,300 for profit and 2,400 for pollution. On the next steps, we will change our status quo point, and every time for new values for status quo point, we will calculate production plan. To change status quo point, every time we will decrease pollution by the same number. For instance, let's decrease pollution by 300 units every time. Why do we choose a step of 300 units? The first reason is that our pollution 2,400 is divisible by 300. And also it will be enough to visualize the Pareto frontier. If you need more detailed solution, so you may take less step. So for instance, 200s and 100s and even less. Let's call the second list Pareto frontier. And here we will consider the status quo point. We assume that pollution is 2,400. We will change our status quo point, and every time we will reduce this amount by 300 units. So, and it will be additional restriction for our model. Once again, we go to the solver, we choose the objective function, profit, and also once again we are going to maximize our profit. By changing variable cells, our variables x1, x2 and x3, and also we add our restrictions for resources, left hand sides, less or equal, right hand sides. And also now we add additional restriction, pollution, the left hand side, should be less or equal our amount 2,400, and also we make unconstrained variables non-negative, and we run optimizer, and as we can see, once again we get our profit 4,300 and pollution 2,400, and now we copy this point to the table. Profit is 4,300 and pollution is 2,400, and also we copy our production plan. And now let's consider the reduced pollution. So 2,400 minus 300, so it is 2100. Assume that this is the new status quo point, and let us try to maximize profit subject to the restrictions for pollution. We run solver, no changes here because all the dependencies are the same, and we run optimizer. Solution is found. Solver found a solution for which pollution is indeed equals 2100. So for this case, we see that we produce nothing for the first product. We produce 200 units of the second product and 300 units of the third product. And here we copy this solution to our table, and also we see that now profit is 4200. So we copy this value to our table, and the corresponding pollution is 2100. Now let's continue with the same step. 2100 minus 300 is 1800. Once again we run solver, and we find an optimal solution. New optimal solution is found, and we see that now the production plan is 100 400. Copy this plan to our table, and we see that now profit is 4100 and pollution is 1800. Now let's continue with the same way, and 1800 for pollution minus 300 units, so we get 1500. And now let's try to find the new optimal solution for which pollution is 1500 or less. Open solver, run optimizer, and we see that solution is found. Now the production plan is 0, and 500, and the corresponding profit is 4000 and pollution is 1500. For the next status quo point, we take pollution 1200. Run the solver. Solution is found, and the production plan is 400. Profit is 3200 and pollution is 1200. The next value is 900, and we run solver. The new optimal solution is found, and the new optimal solution is 300. Profit is 2400 and pollution is 900. The next value for pollution is 600, and we run solver. Optimal solution is 200. We copy this into the table, and the profit is 1600 and the pollution is 600. And also we assume that pollution now is 300. We run solver. Optimal solution is found, and the optimal solution is 100 and the corresponding profit is 800. And the pollution is 300 units. And also if I assume that pollution restriction is 0, so when we run solver, so obviously we find an optimal solution, but the production plan is 0, 0 and 0. So, and the corresponding values for profit is 0 and for pollution is 0. As a result, we found several production plans, and all of these production plans are Pareto optimal solutions. Because if we consider, for instance, the first production plan, there is no another production plan which is by all criteria, I mean profit and pollution, equivalent to the first production plan, and at least by one criterion is better. No, all the other solutions are worse by the criterion profit. So, because for the first production plan we have the maximum profit. As a result, the first solution is Pareto optimal. Also, if we consider production plan 0, 0 and 0, so there is no another plan which is by all the criteria equivalent to this plan, and at least by one criterion is better. All the other solutions are worse by the criterion pollution. So the last production plan is also Pareto optimal, and also we may check the same way that all other solutions are Pareto optimal. Now let's construct Pareto frontier. For this reason we choose the first two columns of our table, go to the insert point, and after that we choose the scatter. And here we see the visualization of our solutions, and the horizontal line is about profit and the vertical line is about pollution. So there are estimations of our Pareto optimal solutions on this graph. For instance, point 0, it is the estimation of the production plan when we produce 0 units of the first product, 0 units of the second product, 0 units of the third product. And also we see that this is the estimation of the production plan of 300s and 200s, and the profit is 4300s and pollution is 2400s. And if our decision maker asks us to find a solution to this problem of this company, so as a result we should introduce him this visualization and these numbers, and our decision maker should make decision which solution to choose. As a result, we discussed multi-criteria linear programming problem. For this case, we implement main criterion method to construct Pareto frontier. Many thanks for attention. See you.